Okay, I'm going to give the perspective from Washington State DOT. Some of it is going to be an overlap with what John covered, and then some of it will be exploring some other performance measures beyond that. But to begin with, as John showed in his presentation, WSDOT, we use equivalent uniform annual cost really for all of our economic evaluations. It's nice because it's a simple value that can directly be compared with other treatments. So I have a chip seal that is not going to last as long as an asphalt resurfacing, but if I convert it to annual costs, I can compare those directly. If I use net present value, I get maybe a misleading idea of a chip seal versus an asphalt, but an annual cost is really the way that I manage the pavement. And so that it's a simpler process, and it's easier to compare alternatives. And also when using EUAC, there's no need to consider salvage value. I can look at just one performance period and kind of simplify the whole process. When we look at cost effectiveness, again, we try to simplify it by first saying we want to evaluate what is an acceptable pavement performance. We don't really try to look at benefit cost. Benefits are really hard to quantify when you're dealing with pavements, particularly with pavement life or pavement quality of performance. So instead of trying to quantify the benefits, instead we just say that it's an acceptable level, and once we achieve an acceptable level, then the only thing we really worry about is minimizing cost. So the objective function is minimizing cost at an acceptable level of performance. Now, performance measures that we can use with these cost effectiveness, one is looking at it historically. And I'll show an example of this, but we should be learning a lot about our past performance, just like any business does, and how cost effective have we been, and why, and where can we make improvements. We have typical life cycle cost analysis looking into the future when we're comparing alternatives and what types of pavement treatments we want to evaluate. And then also we can look at Easel efficiency, because if we take that annual cost and divide it by the Easels that we're carrying, we can see how effective different pavement structures are at carrying Easels. So I'll do a little example here, but of just the simplicity of the annual cost. We've got let's using it as an easy example, a $250,000 per lane mile asphalt resurfacing. And just using the EUAC formula to calculate the annual cost using a 4% discount rate, you get to $26,600 per lane mile per year for an annual cost. So it's a very simple representation. But if I want to compare that then with a preservation treatment, maybe I spend $5,000 per lane mile in year 10. Maybe it was a crack sealing treatment. Maybe I spend $15,000 per lane mile in year 15 with maybe a different type of treatment. But what I've done is I've extended that time period from 12 years out to 15 years. Well, now I've spent extra money, but I've also extended the life. So that results in a $23,500 per lane mile per year cost. So the result is a 12% reduction in the annual cost. And it can be just as simple as that, comparing the preservation treatments with the annual cost, showing that I've spent additional money, but it's resulted in a lower annual cost. And so using that method, then I can document the savings for all kinds of different preservation treatments. And I also have a table similar to John's with our annual pavement costs. One of the things that, in order to compare Oregon's, and my numbers are quite similar to John's, But one of the things, if we wanted to compare the annual costs between Oregon and Washington State, is we have to ask the question, well, what goes into this total cost calculation? Do we include engineering costs? Do we include traffic control costs? In Washington, we include sales tax. Oregon doesn't even have a sales tax. So we really need, if we want to start using these as performance measures to compare state to state with how cost effectively we're managing our pavements, we really need standards to define what goes into these cost effectiveness calculations. Another thing you can see here, similar to John's, is that the chip seal on an annual cost basis is 2 to 3 times less expensive than an asphalt pavement resurfacing. So based on this, we've implemented a program in Washington State. We're about halfway through it, where we are basically expanding the size of our chip seal network by 50%. Because we have roads that we think are appropriate for a chip seal, and not all roads are. Usually these are for lower volume traffic roads. But if those currently have an asphalt surface, we are converting those to a chip seal surface. So looking at these performance measures, there's our annual cost here, dollars per lane mile per year. This is historical, so we're looking back. And this is for one region, and this is only for asphalt pavements. We could do these for different types of pavement structures. But the blue columns are urban roads, and the red columns are rural. We would expect urban performance to be more expensive than rural. But this is a statewide average, and if we look at the averages for different regions, we have 6 regions in Washington State. We don't really see a big difference region to region, and so as a performance measure, we could use targets. We plan on developing targets for the regions to make sure that they are managing their payments in an appropriate manner. But if we drill down into one of these regions, we see a lot of variability. So this is showing just one region, the South Central region, and on the left-hand side is this dollars per lane mile per year. But you can see that there are some, and this is for individual projects, individual contracts. You see that some have very high costs per lane mile per year, and some have very low. So going back and understanding what happened with those high cost contracts, and there's little green triangles in this, so what that shows is how many lane miles were in that project. So we may get a spike like this one here, but if you look down, it's only a few, well actually it's only about 3 or 4 lane miles. So maybe this was rebuilding an interchange where you would expect, okay, the costs are going to be significantly higher. But some of these routes have very high lane miles and the costs are very low. So this indicates that the way that we have designed and maintained that section of road has been over the years. So we're looking historically at what we have done has been a good performer, so we should try to learn from what we did there and how to repeat it. And then those contracts which are very expensive, we should try to figure out what we did wrong and try not to repeat those. So this is a real valuable tool using that cost effectiveness information. This is another example of that, but looking at cost effectiveness by location. This is a screen print from our pavement management system, and I'm not going to go into details here, but you see this kind of purple area here. On that diagram, that purple area means it's a chip seal surface, and then this black area means it's an asphalt surface. But you can see over time that chip seal has been managed at a very low cost, and then how the costs spike, this dollars per lane mile per year, once we hit that asphalt section, and then they tend to level out. So this area here with a high cost, we should investigate what happened there. And there are details I won't go into where there were some issues with the road, and it did take some additional repair and restoration for that particular segment of road. But we can look back and see exactly, on a quantified basis, how much we did spend in order to get that level of service. And we can see that the difference between a chip seal and an asphalt surface. And as it so happens, this line right here between the surface types, one is one region of our state and the other is another region. So it's right at the region boundary where that section of road was managed by two different regions. Now, this has been converted to chip seal, because we can look at how we're managing different pavements in different ways, and we can see that it was much more cost effective to do it with a chip seal surface, and so that caused the decision to convert this to a chip seal surface. And then we also have the dollars per easel that I mentioned. Here we can see that these numbers here are about 25 cents an easel, and that's kind of the range we get on a low volume road, about 25 cents per easel. But if we look at that on an interstate highway, it's down to 5 to 10 cents per easel. So an interstate highway is built for and very cost effective at hauling freight. So it's just another example of how we can use these numbers to evaluate our previous decisions and also to help us make better decisions for the future. That's all I've got. I'll turn it over to you.